my today's session of network analysis. Today we are going to discuss about the transient and steady state fundamentals. This is a basic of the network analysis. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering in Institute of Aeronautical Engineering. So what is the main course objective? The course objective is the present the mathematical background. Today we are going to discuss the mathematical background of the transient analysis for DC and AC study using, and in later class we will discuss about the differential equation. What is the course outcome? The course outcome is to understand the concept of initial conditions of the RLC elements to determine the transient response for first order and second order electrical circuits. So, before starting, first we are going to discuss what is the meaning of stability. What is stability actually? The ability of the system to return to its normal or stable conditions after being disturbed or change in input is called the stability. So what is the definition? The ability of the system to return its normal or stable conditions. So what does it mean? Let's say we have I'm giving one normal example from our household. We have a fan and we switched off the fan. We know the switch offing the fan means the fan will be in the stationary condition. But you can find whenever we will switch off the fan, it will not stop at that instant. Due to its moment of inertia, it will take some time and ultimately it will stop. So this stop condition is a stable condition. Or say we want to run a fan or run a motor in 1500 RPM speed. What will happen? Slowly it will increase its speed and ultimately it will gather the 1500 RPM. So that is our stable condition. So the ability of the system to return to its normal. What is our desired input? We are getting the desired result or the stable condition after being disturbed. If we are suddenly say we are switching on a fan or switching on a motor, suddenly we are there is a voltage fluctuation. What is this? This is called the disturbance. So due to the disturbance or change in input means your fan is in your regulator fourth. You change it into the fifth point or third point. So the voltage level will be increased or decreased. So that is the change in input. And after that, when it is again gaining the stable condition, it is called the stability. In your house also, on the fridge, if you are going for the old fridge, you can get the stabilizer. What is the use of the stabilizer? If the voltage level is more, it will stable the system. So, disturbances of the system may be various types like sudden changes of load. Sudden changes of load means say the current is increased or decreased. Sudden short circuit between the line and ground due to the fault, line to line fault, switching from one switch to another switch. So for the different condition, there may be some change in the input or there is some disturbance, and due to the disturbance also, when it is returning to its normal or stable condition, it is called the stability. Next is the time response. What is the meaning of the time response? If the output of an electric circuit for an input varies with the time, then it is called the time response. So if with respect to time, if the inputs are changing, say we have a sinusoidal input, so this is the time response. Say we have a DC input. DC input means a straight line. This is also a time response. So if the output of one electrical circuits, if the output of an electric circuits for an input varies with respect to time, then it is called the time response. The time response consists of following two parts. One is called the transient stability, another one is called the steady state stability. What is the transient stability? As I told, when you switch off the fan, it will not stop instantaneously. It will slowly decrease its speed and it will come to a stable condition. Or say, for anything, this is the transient for the switching on and switching off when it is coming to a changing, and when it is becoming a constant, this is called the steady state wave and this is called the transient stability. So stability is two types. One is called the transient response, one is called the steady state response. Today our main class is based on these definitions of responses. So first we will discuss the steady state response. A DC circuit having constant source, actually the input for an electrical circuit is two types. One is called the DC or direct current, another one is the AC, alternating current. So the input of any electrical circuits may be two types. One is called the DC input, one is called the AC input. So how the system changes with the change of the input. A DC circuit having constant sources is said to be steady state because and current and voltage do not change with time. So in this, if we draw a DC input with time, any current graph, it is always a constant in a fixed value. So a DC circuit having constant sources is said to be steady state because the value of currents and voltages do not change with time, and the current and branches in all branches remains also constant. So all are in the steady state condition. I will show you one example for this. Say we have a circuit like R, and this is a voltage source which is DC. So everywhere when the current is going, as this is a current source, for one constant resistance, if it is 10 ohm, it is 10 ohm, it is 10 ohm. For this all the resistances, current is always constant. So this is the steady state response. What happened if we are giving an AC source here? If we are giving one AC source here, through the source voltage and current is alternating, and the branch current and branch voltages are also not constant because their amplitude and frequency is constant but its phase is changing. So but when it is constant, we are calling it the steady state condition. So in the case of the AC source, though the voltage and current is changing, if we want to plot the amplitude and the angle, amplitude and the frequency, both are constant. So in the last class, we have drawn the phasor diagram. In the phasor diagram, when we are drawing the phasor diagram, we are not drawing the amplitude only and the phase angle only. So this is constant throughout the system. So this is also called the steady state analysis. The angles are not changing, so it is called steady state condition. So we can think what is the steady state condition. Say we have a ball and it is a hole. So we are giving some force. This is the state 1. So what is this condition? This is the steady state condition of the ball. Now the ball is falling and it is dropping. Whenever the energy is losing, the ball value, the height is also decreasing. So the total, and again it is coming to a constant. Either it is moving in a constant speed or it is stopped. So what is the thing? The thing is ball is dropping, the energy is losing. So this is the steady state condition. This condition in state 1 and state 2 is the steady state condition. Next we are moving to our next one. What is the next one? The next one is the transient response. So after applying the input, we are giving this example, we are kicking the ball. After after applying the input to an electric circuit, the output takes certain time to reach the again steady state. So in between this area you can see the energy is decreasing and it is dropping. So after that, when the rate of change of energy, remember the word, this is rate of change in energy is equal to 0, then the system will be in the steady state condition. So when this energy is there, this is called the transient condition. Therefore, the response of the electrical circuits during the transient state is known as the transient response. The transient response will be 0 for large value of t, and while t should be, and ideally t should be infinity. So what does it means? That if we draw this, it will go and it is the stable condition. Generally, from the control system or electrical engineering view, we are thinking if the level is within plus minus 2%, then we can tell one system is stable. You can see this is our desired output. If it is in the plus minus 2% value, we can tell it is a stable condition. Otherwise, we are thinking this is not a stable condition. So the transient response will be 0. The transient will be totally die out when t has a very large value or t will be infinity. So what is that mean? This means that again the fan example we are taking, when you are switching off the fan, slowly it will stop and it takes minimum 1 minute or 30 seconds for this to stop. Not immediately t is equal to 0, it is stopping. So this is called the transient response. So what is the transient response? We can tell that the transient response in electrical circuits is happening for the 3 causes. Transient response occur due to the sudden change in the source. This may be change in input. This may cause for change in input, or it may cause in change or the presence of the external or internal disturbances. So transient occur in the response due to the sudden change in the source, that is change in input or change in disturbances that are applied to the electrical circuits and or due to the switching action. There are 2 possible switching actions in any electrical circuit. We know if we suddenly close the switch, once something is open, we open the switch. Open the switch means that it is disconnected. Disconnected means again some transient will occur. Or if we close the switch. If we close the switch means we are switching on, the current will get one path. So this is also the example of the transient response. This is the transient response causes due to 2 times, either for the switching, opening of the switch, or the closing of the switch. Then what is the meaning of the present? When we can think the presence and absence of a transient in electrical circuits? We have discussed that transients occur in the response due to sudden change in the source. So if there is any sudden change in the source, we can tell there is the presence of a transient. So what is the cause of the sudden change? Due to the switching action. Sudden change means, as I discussed, one is the input change. Input change means in the fan we are changing the regulator. So the voltage has been increased or decreased. So input change. And number 2 is disturbance. Or any disturbance means any circuit there is any fault in the circuit, any short circuit or any type of disturbance is there. The transient part will not present in the response of an electrical circuits of a network if it contains only the resistance. If it contains only the resistance, there is no presence of the transient, because resistor is having the ability to adjust any amount of voltage and current. And one more thing, that as I told, what is that when the transient will present? If there is a rate of change of energy, it may be increasing, it may be decreasing, but if there is a rate of change of energy, then only we can tell that the energy, the transient will present. But in the resistor, this is not an energy storing element. So if there is any change in the voltage and current, it is able to adjust the change. No energy is storing here. So we can tell this is a absence of transient. But on the other side, the other passive elements like inductor and capacitor, the transient part occurs in the response of the electrical circuit or network due to presence of energy storing elements such as inductor and capacitor. As this is the directly related to the energy is stored there, so it will affect due to the rate of change in energy. So because they can't change the energy stored in those elements immediately. If the voltage is changed or sudden change in any input, the energy stored in these things cannot be changed immediately. It will take some time, and only for this the transient will present in the passive elements like inductor and capacitor. So we know there are three types of passive elements. One is resistor, one is inductor, one is capacitor. Resistor do not affect due to the transient, but if inductor and capacitor is present, it will affect due to the resistance. Next, we will discuss about the cause of transient. In a network containing energy, in a network containing the energy storage element, with the change in excitation, the current and voltages change from one state to another state. So, if the energy storage element, inductor and capacitor is present, then with the change in excitation, the voltage and current will change from one state to another state. That's why it will cause some transient. Therefore, the circuit change occur whenever the circuit consists about the inductor and capacitor. If there is the pure resistor, there will be no transient condition. The inductor and capacitor has a certain peculiar characteristic because of which it changes occurs in the circuit. What are the characteristics? Inductor will oppose the rate of change of the current. And what is the use of the capacitor? Capacitor always oppose the rate of change of voltage. So as they are opposing some rate of change of current or voltage, and in the power, what is the power? Power is equal to V into I. So if there is an inductive circuit, the rate of change of power or energy means dV by dt, V into I. So if V is constant, di by dt. If there is a rate of change of current, inductor will oppose it, and which will creates the transient of the system. It is, though we are drawing the transient of the system like second order system like this, but not necessarily the transient will be always like this. The transient may be, say we want to improve our voltage, so transient will increase in an exponentially increasing. Or if we have a capacitor, we have suddenly switched off the capacitor, what will happen? It will suddenly decrease it, and it will be the, again it is an exponentially decreasing. So these portions are the transient. This portion is the transient portion. So these are the example of the transient portion. Next, so if we want to write the gist, what are the cause of transient? A change in interconnections within the network. If we change the RLC connection suddenly, some sudden disturbance is there, sudden short circuit is there, it may cause the transient. The change in the element value, suddenly the capacitor value we increased, or suddenly we decrease the capacitor value, suddenly we increase the resistor value. In the fan, we are using the regulator, we are increasing or decreasing the resistance value, or a change in the nature of excitation. We are giving 10 volt, suddenly we are giving 20 volt, and presence of disturbance. So any type of disturbance, sudden voltage increase, sudden current increase, this will occur the transient in the system. So these are the main cause of transient of a system. Next, the transient response. The behavior of the voltage or current when it is changed from one state to another state is called the transient state. So say we are going from here to here like this. So this is the transient state. So the behavior of the voltage and current when it is changed from one state to another state, one side to another side, is called the transient state. The time taken to come from one state to another state is called the transient time, and it is written by TR. The transient changes are assumed to occur at t equals to 0 and represented at the switching. As we told that the transient may occur first and foremost is the switching. So switching on or switching off time, we are taking it as the t equals to 0. The switch may be supposed to close or open at t is equal to 0. It may be closed or it may be open. So it is represented at t is equal to 0 due to the switching phenomena. The switch S is assumed to be an ideal switch which makes or breaks the circuit in 0 time interval. So what is a switch? Switching means it is an ideal switch. We are thinking there is no drop, no energy storing in the switch. It is an ideal switch which can make or break the circuit at exactly time t is equal to 0. And just at the time of switching, it will make or break the circuit, no delay. T is equal to 0 minus is called the a prior or instant prior to t is equal to, so it is called the a priori system. A priori system means just before the switching. The condition just before the switching, the condition just after the switching, and this is called the post priori system. The condition just before the switch is operated, and we are writing about I0 minus just before the switching, V0 minus just before the switching, and conditions we write just after the switching as I0 plus V0 plus, like this. The response changes from an initial steady state to the final steady state is known as the transient period. As we drawn before, the time taken from one initial state to the final state is called the transient period. So if we draw like this, so this is the transient started, transient ends. So this time can be written as this time is called the transient period, or transient time, we write it by TR. The response is known as the transient response and the output is known as the transient response. Next important thing of this topic is the initial conditions. What are the initial conditions? So before we can solve any transient problems, we should know the initial conditions of the inductors and capacitors. We must understand what is basically the initial conditions of the differential equations. So let's think about a capacitor. Say we have a capacitor. What is the definition of capacitor? Which will hold some charge. So we know the capacitor V is equal to Q by C, or we can write C is equal to Q by V. So say we have a capacitor and we have connected with a voltage source. So what will happen? It will start to, when it is switch is on, it will starts to charge. It will starts to charge. Now we will open the circuit. We have opened the circuit. What will happen? The capacitor, the general tendency of the capacitor will starts to discharge. It will, as there is a rate of change of voltage, the voltage is sudden, there is a sudden change in the input, so it will starts to decrease. So this is the transient condition. Now if it starts to decrease, again if we connect the circuit, it will starts to increase. So you can find here, it is not becoming zero. The charge in the capacitor is not becoming zero. So this is the transient condition. Same thing we can discuss for an inductor also. Let's take an example of a solenoid. So what is a solenoid? Solenoid is nothing but a iron bar on which we are keeping some conductor. Now we are connecting it with the source. So say we are giving one AC source. So what will happen? There is a rate of change of current. Now you can see that in the iron, when it is not magnetized, what will happen? There are some molecules, all the atoms will be aligned in a puzzled manner. So there is no property of the magnetism. But if we connect it with a source, what will happen? It will be in a north and south pole manner. It will be in the north and south pole manner. Now if we are disconnected the circuit, what will happen? Though we are changing the input, though it will be in the some alignment will be always present in there. So some residual magnetism, this is called the residual magnetism, will always present in the system. And based on this, we are making the machines in the electrical machines is working on this, that while we are switching off the motor, it has some residual magnetism always present in the system. So these are known as the initial condition. Mathematically, though it is zero, but practically there is some value, and this is called the initial condition. So what is the initial conditions of the parameters RLC? Resistor, for an ideal resistors, we have no initial condition, as this is an energy dissipating passive element, so it cannot store anything. The voltage across the resistor will change instantaneously if current through it changes, and vice versa. What is an inductor? The current cannot change instantaneously because the property of the inductor, it will oppose the rate of change of current. So an inductor will not allow any sudden change in current through it. So for the always I0 minus is equal to I0 is equal to always I0 plus, means instantaneous current at the time of switching, just before the switching and just after the switching, the inductor initial conditions are always same. Inductor, the current cannot change, as I discussed, if the switch is closed so as to connect the inductor to the source of energy. It will not allow the current to flow at the initial instant, and the inductor will act as if it is an open circuit independent voltage source. So if there is a change, it will behave like an open circuit and it will not allow to change the current instantaneously. However, if the current I0 flows through the inductor at the instant of switching, the current will continue to flow and the inductor can be thought as a current source. So, inductor, if we are switching of the, so there are two conditions. There is a switch, it is closed, and we have opened the inductor. What will happen? As there is a discontinuation of the current, it will behave like a current source and it will force to flow the current. So, two conditions. One is switch is open, we closed the switch, current will flow, but the inductor will not allow to flow the current instantaneously. The switch is open, we close the switch. At the time of switching, the inductor will not allow to flow the current because it will not change instantaneously. So the initial condition, it will behave like a open independent voltage source. Similarly, this is a closed off switch and suddenly we open, then what will happen? It will oppose to flow. So it is the current source. What will happen to the capacitor? Capacitor will not allow to change any sudden change in the voltage. If any unchanged capacitor is connected to an energy source, then initially the voltage across it is 0 and then it will start to increase. But when it is uncharged, they will not allow to increase the voltage. So it will initially act as a short circuit. If an initial charge Q0 is already existing, V naught is equal to Q naught in by C. The capacitor will be equivalent to the voltage source V naught. So what is the steady state response of an inductor for the DC excitation? If the independent source is connected to the electrical circuit or network having one or more inductors and resistor for a long time, if we are giving it not about the switching, transient is over. Now we are coming to the steady state portion. Now, if it is a resistor, it will be always in the steady state condition. But if it is an inductor, what will happen? If the independent source is connected with an electrical circuit for a long time, then the electrical circuit of the network is said to be the steady state. Say we have a R, we have a L, and we have connected with a voltage. We are connected to a voltage source, DC voltage source, and the switch is closed for a long time. At the time of switching, there must be a transient due to the change. But the circuit is closed. What will happen? We know that the current through it is equal to V by Z. What is the meaning of V? R plus J XL. What is XL? XL is equal to 2 pi FL. So as this is an DC and frequency is equal to 0, so XL value will be 0 and it will behave like a short circuit. So what is happening here? It is happening that the energy stored and the inductors will be always maximum and constant. Therefore, the inductors acts as a constant current source in steady state. It will behave like a constant current source in the steady state condition. The inductor acts as the short circuit, as we wrote, omega L is equal to 0. So it will behave like a short circuit. What will happen for a capacitor? If the independent source is connected to the electrical circuits having one or more capacitor, it will be behaved like a steady state. The energy stored will be the voltage, energy stored in the capacitor will be the maximum, and as we know, if there is a capacitor, current will be again voltage by R plus J XC. What is XC? XC is equal to 1 by J omega C. Again, omega is equal to 0. So, XC is equal to 1 by 0 means it is infinity. So, therefore, the capacitor will behave like a constant voltage source in the steady state and it will behave like a open circuit as the impedance is infinity. What does the physical significance? The physical significance means it will behave like a capacitor, open circuit. So two things we got: in a steady state condition due to the DC excitation only, not AC excitation. It is AC excitation frequency is always there. For a DC excitation, the inductor will behave like a short circuit constant current source. Inductor will behave a short circuit and constant current source. What about the capacitor? It will behave like a open circuit constant voltage source. And this question is very very important for any interview and for any interview type interviews. So these are the textbook I have discussed, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.